next invited speaker, Dr. Hamdi Rifai from Departments of Physics, Faculty of Mathematics and Natural Science, Universitas Negeri, and he's an expert in volcanic and also magnetism. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say thank you to committee to invite me as an invited speaker here. Ladies and gentlemen, good afternoon all, and I would like to present my exploring volcanic eruption activities using magnetic proxies. This is research collaboration with NTU, with also with Jen, and also with other university in previous year. And this includes student here, undergraduate student and also graduate student. This is my roadmap around. Right now, I'm here. This is in Sinabung. We go together to Sinabung, and we know that Indonesia part of Ring of Fire, and many volcanic here, like this one. The red one is to figure it, the fire under land, and we have in Southeast Asia is around 100 million inhabitants, and so many volcanoes have been active in the past 100 years, and in other this volcano close to the equator. And this is the first volcano eruption. For example, this is Sinabung, and this is Sinabung, and this is Krakatau, and this is Merapi eruption in Central Java. And we can see that the part of eruptions going up the ash, the volcanic ash. Ladies and gentlemen, if eruption happen, so a lot of ash come out from the volcano, and it is the ash can fly to far away from the volcano. Let's say 100 kilometers, 1,000, and maybe more. So, yeah, like Pinatubo in Philippines, we can see the ash come to Singapore. Ladies and gentlemen, why we interested to research about the volcanic eruption, especially for paleo eruption? We can see that this is Sumatra, Sumatra, and a few researchers do it about talking about the volcanic here, and so many researchers come to Java to explore or to research this volcanic activity here, and also Bali, Nusa Tenggara, and this is because of that, we want, with my collaboration in TU, we want to explore this one to know that how many eruption happened before and how big, and yeah, something like that. Next, this is a kind of environmental study where we focus in the land, then here, where for detection of environmental change, we can use the proxy like pollen, isotope oxygen, magnetic properties, and also and sample trees, coral, loose ice core, lake or deep sea sediment, and also speleothems. And before I focus with stalagmite and stalactite too, and also sediment cave that we call with guano. And right now I focus about the quaternary sediment of Sumatra and also rock, volcanic rock. The aim of our study is to attempt to use magnetic characters as fingerprint for volcanic eruption in Sumatra. The role of environmental study. In fact, many Indonesian volcanoes have erupted. In concept, while eruption, volcanic ashes can transport to long distance that carried by wind blown and one of magnetic mineral source. And then the principle, the natural event should be recorded in environmental, and how to study, we use the rock magnetism methods. Why rock magnetism methods? Because of rock magnetism method has played a major role to study magnetism. And then the magnetic properties is one important environmental change process and easier to measure. And yeah, this is from my teacher and also my colleagues Santoso and Sudarninsi. And sediment and rocks are relatively open to environmental change and also people activities. Ladies and gentlemen, so what is recorder of natural event? Let's see if we go to, this is North Sumatra, we can see pumice in the land, a lot of pumice in here, and also we the recorder, the good recorder is peatland and so lake and also cave. Yeah, that is the good recorder of natural events. And this is the study area. For the first time, we focus on West Sumatra, especially for Lake Maninjau and peatland di atas, and also di atas, Lake di atas, and then we go to Kerinci too to find the pyroclastic, and this is where we collect the sample, and here where we collect the sample too. This Maninjau Lake, and this is Lake di atas. And for take the sample, we use the pit core, yeah, pit core here, and this is Danau di atas, and this we collect the rock from around Maninjau and also di atas, and some sample we collect from the cave. And method, we use Bartington magnetic susceptibility and mini spin magnetometer. We know that this is useful for to know that concentration of magnetic mineral in the sediment or in sample, and we want to know the intensity of magnetic, and we use SRF, SEM, and XRD to identify that element and the profile of the magnetic mineral, and also to know the kind of the type of magnetic mineral. And this is my collaborator do it. Yeah, it is. Yeah, we go next. And the result of my study, this is the sample got from Maninjau, around Maninjau. And this is the magnetic susceptibility value with low field magnetic susceptibility, and this is high field magnetic susceptibility, and this is percentage of field dependent susceptibility, frequency dependent susceptibility. I mean. And after that, we try to to know that the domain of magnetic mineral in Maninjau, for example, and we know it is like multi-domain magnetic, and this is only one super paramagnetic single domain. And then for the atas peatland, the first time we scan the core. We scan the core that's deep around 100 centimeter deep, and we got the peak in here, and we try to plot and also surround multi-domain, and then we check with SEM like this one. So for example, this one, this spot, and this is dominantly irons, and this is also iron dominant. So this is the type of titanomagnetite or titanohematite, and this is maybe magnetite. And this is also like that one is not, but this is a really different between the dark one and the light one. The light one is amount of iron here, and this is less iron here. And this is other grain with different shape. Yeah, we can see that it's this hole here, and the shape sharper, yeah, than other grain. And then we try to check with XRD. There have magnetite, hematite, and also quartz. And for this for this grain, we can see that we can interpret it that this look like directly come to the area. Because of there are no broken edge here. So this is, I think, this is natural from the source, still natural from the source, and we can see that it is quite similar. The element quite similar here. For other sample, yeah, we can observe too the magnetic susceptibility of from Solek in West Sumatra to and Goa Batu Payung, and this is in Kalimantan, Borneo, and this is also on Borneo. Then we check with IRM curve. That's the type of magnetic mineral are magnetite, and this is also magnetite. And when we check with the S ratio, is also dominantly magnetite. And when we check with the RMDK curve, and this is look like decrease suddenly, very fast. And we know this is from the king plots. We know that this is also multi-domain. Yeah, big size of the grain of magnetic. Then next analyze is the grains, and then we check the correlation between the grain size and low field susceptibility, and it is correlated, very correlated. I think a good correlation are with coefficient determination around 0.9. And then this is similar with the previous slide, and we also check the age of a part. This is still in progress because of quite long to analyze the age. We have got 2,305 before present, and the lower part around 8,100. So in this set, we can conclude that we found the variation of magnetic concentration in size, shapes, and type in sediment, ashes, and also rock. Then the variation of susceptibility low field in suspended sediment from volcanic areas is tropic different significantly from the sediment from non-volcanic areas. It is Sudarningsih, and then predominant magnetic mineral volcanic material around West Sumatra was found to be Ti-rich titan magnetic with multi-domain magnetite. And then multi-domain magnetite can interpret that the material come from closed source. Yeah, I would like to say thank you to Kemendikbud Dikti and also to EOS and TU Singapore to for the budget to go to a field trip, and also to for analyze the sample and everything, also like conference, workshop, and so on. Thank you.
Thank you very much, Doctor, for interesting topic. Maybe we can open the Q&A session for now. Any questions from the floor? Any questions? Okay, no? Okay, if no question, thank you very much, Dr. Hamdi.
It's understandable.
Okay,
Thank you.
before the end,
Assalamualaikum warahmatullahi wabarakatuh.
I will make a conclusion saying that from Professor Dr. Baba Musta saying that mineral weathering causes to physical erosion by weathering to bedrock, and finally it will produce soils. While for Dr. Hamdi Rifai said that magnetic has its own characteristic in volcanic eruption in Sumatra. So what I can conclude here is that all of us here are from different background, different field, which we are here in geochemists, geophysics, and geologists. Same like magnetic force philosophy, where we have different pole and different charge where it can attract to each other. Same goes to us here. So even though we are from different field, but we are united under one conference, which is ICE-R3M. So congratulations to us.